This is chapter 6.2 textbook homework problem solutions. The first three problems were problems 9 through 11. They're the same types of problems. Determine which of the following probability experiments represents a binomial experiment. This is what we did in our notes too. It was one of the first examples. And so in order to answer a question like that again, we need to refer to the criteria for a binomial probability experiment. And here they are. Remember, it's really dependent upon that we have two outcomes, something we call success or failure, that those two outcomes are mutually exclusive or disjoint. We have a fixed number of trials, meaning that there's a finite number of trials we're doing, and that those trials, the outcomes are independent of each other, meaning one does not affect the other. And that the probability of success does not change for each of those experiments, each of those trials. An experimental drug is administered to 100 randomly selected individuals with the number of individuals responding favorably recorded. And so in this case, this is yes, we have n equals 100. In this case, we don't have the probability here, but what we're going to record here is success means that they they either favor or don't favor. So my outcomes, there's only two outcomes, right? There's two outcomes, either favor it or not. So this is a binomial probability distribution experiment. In this case, 1,200 voters is conducted. A poll of 1,200 voters is conducted. So I have n equals 1,200. Are asked whether they believe Congress should reform Social Security. And so here again, this is a yes also. We have two outcomes. It's either yes or no, should they favor. 3 cards are selected from a standard deck of cards without replacement. Without replacement, this is like our example, I guess, where we had the number of aces selected is recorded, and so in this case, this is not a probability distribution. We have a couple of things going on here. In this case, if you want to think about an explanation, let me see if they have writing here so you guys can look at some of those. There's the answers for 9 and 10 briefly. You can pause it if you want to read the answers for 9 and 10, even 12, 13, and 14 you want. But for number 11, it's not a binomial probability experiment because trials are not independent, right? So once you get, the probability of getting an ace changes each trial. So those probabilities get updated because without replacement, you're reducing the number of cards in the deck. And so the probability of getting ace on the second card depends what happened on the first card. So there's a dependence there. Okay, so that one is a no, not. Let's go ahead now and look at problem 36. 36, so we're going to do some calculations here. So give us some space to write some information here. And the Gallup organization found that 45% of adults believe the overall state of moral values in the United States is poor. Suppose a survey of a random sample of 25 adults is conducted. And so let's get some information down here. We're going to be asking 25 adults. So there's our 25 trials. The probability of someone saying that moral values is poor is 0.45. 1 minus p is 0.55. Remember, if you're looking at some people call that Q. We have those informations, that information. So find and interpret the probability that exactly 15 of those surveyed feel the state of morals is poor. So we're trying to find the probability that equals 15. And so we go to StatCrunch for that instead of that complex formula. And so in this case, the calculator we're looking for is binomial. The values we care about in this case are going to be, I better look them up again, 25 and 45. So let's put a 25 in there. Probability of success means someone says Morals are poor, and we wanted the probability out of those 25 that x equals 15. So we turn that to 15, make that an equal sign, and you got it. So it's 0.052. There we go, 0.052. So this is 5.2%. That if we asked a large group of samples of 15, I'm sorry, samples of 25, we would expect that 5.2% of those samples, we would find exactly 15 people saying they think morals are poor in the United States. Part B. Let's look at part B. Find and interpret the probability that no more than 10. So that's the probability that no more than 10. So that is x is less than or equal to 10, no more than 10. And so we have the same situation here. And so we're going to change this to a less than or equal to. Let's turn that to 10, compute. And so then we have it here. And I kind of like this StatCrunch gives a picture. You can see the ones in red are all the ones that are no more than 10. So in this case, the probability is 0.384 or 38.4. So 0.384 here. So that turns out to be 38.4%. Find in terms of probability that no more than 10 of the 25 surveyed would say. So there's a 38.4% chance that 10 or less, or no more than 10 people will say that morals are poor in the country. So that's problem number 36. Let's go ahead and look at problem number 41. 12 jurors are randomly selected from a population of 3 million residents. Of the 3 million residents, it is known that 45% are Hispanic. Well, we're going to have the same p-value, looks like. Of the 12 jurors selected, 2 are Hispanic. So think of the situation of why would do we think 2 is an unusual amount? It'd be an interesting question, right? And so out of 12 given the composition. And so 12 jurors are random selected. So first, what proportion of the jury described is Hispanic? So what we know is 2 out of 12 or 1 out of 6 is Hispanic, and 1 out of 6 is 0.166 or 16.7% of the population of the jury. And so we also know that 45% are Hispanic of the population. So it seems like we could be underrepresented. So let's calculate the probability that that could happen. If 12 jurors are randomly selected, what is the probability that 2 or fewer jurors will be Hispanic? So we're looking at this here. Probability that X, 2 or fewer jurors is selected. And so, because we want to find out is this unusual, and so looking at it, we have the 0.45, but in this case the n is 12 in this case, and we want 2 or fewer in this case. And so the probability of selecting 12 people when 45% chance of someone being Hispanic, which was our success there, what's the probability that only 2 or fewer will be Hispanic? And so we end up with 0.042% chance, 0.042, which is 4.2%. So the probability that we would only get 2 out of 12 Hispanic jurors given the composition of our population is 45%. Because if the population was, let's say, 50%, we would think it would be 6 out of 12 should be Hispanic. Well, at 45%, what would we expect? We can do that calculation, but what we know is 2 or fewer seems too small. Seems like maybe something's up here. If you were a lawyer for the Hispanic defendant, what might you argue? I think since 4.2% is less than 5%, I would say I would say that this vent, I would say can't get the writing in there. I would say that this is an unusual event. Why is that? Because it's less than 5%. And so I might argue that there's some bias. Think about this again, really, before you move on, think about why I've come to this conclusion. We would expect at 45% Hispanic population, we'd expect more jurors, right? We would expect approximately 45% of 12. So we would expect between 5 or 6 jurors. We only got 2. Is that unusual? We calculated, yes, it is unusual. So we would argue there's bias in the selection. And let's finish the homework with problem 45, toilet flushing. In the healthy hand washing survey conducted, was found that 64% of adults operate flushing toilets in public restrooms with their foot. If 500 adults were randomly selected, how many would we expect? So in this case, how many would we expect out of 500? We would expect 500 times 0.64. That's what we would expect. And I'm going to calculate the standard deviation because down here, would it be unusual to observe 280 adults? We're going to answer that question. We need to know what the standard deviation is. So I'm going to answer it right away here too. Oh, in this case, we do need to answer that problem there. And so for that there, let's look at that answer real quick. 45. Problem 45, correct? Yeah, 45. So looking at problem 45, we'll get there, a lot of calculations. Where is it? Oh, problem 45, there it is. We would expect 320 adults, and then the standard deviation is 10.73. So 320 and 10.73. And so we get 320 here. And then to calculate this here, I better go back to that. It's going to be 500 times 0.64 times 0.36. And then, like I said, that's standard deviation. We need to do that by hand, not by StatCrunch. And then we got 1073 there. 10.73 standard deviation. So would it be unusual to observe 200 adults who flush toilets? And so there was a check we needed to do. Remember, it was n times p times 1 minus p has to be greater than 10. This needs to be checked first before we can actually apply the empirical rule. And so if we look at it, it's going to be obviously going to be a bigger number. 500 times 0.64 times 0.36. It's greater than 10, so we're okay here if we do the calculation. And so now we can use the empirical rule. So we're going to use the mean plus 2 standard deviations, the mean minus 2 standard deviations. And so we're looking for unusual events. We know the mean is 320. Our standard deviation is 10.73. So you do 320 plus 2 times 10.73. We do 320 minus 2 times 0.73, and we're drawing this table, this x-axis like we've done many times before. And so when we do those calculations right there, we end up with kind of our limits of our interval. And so in this case, the one we really care about is the ones below. And so when we do that calculation, you get 298, 534, 298 for this one here. That's 2 standard deviations right there. So this is 298, 534. And it says, is 280 unusual? 280 is right here. So the answer then is yes. 280 is unusual. I didn't need to do the above one because I was looking for 280, which is I just needed the below one. And so then we can say it is unusual for 280 adult Americans to flush toilets in the public restrooms with their foot. And that was again using the empirical rule. And the only reason we could use the empirical rule is because this statement was true right here, which was in our notes I had showed you. That's it. So it looks like I forgot to do problem 36, C, D, and E from the homework from chapter 6.2. So we're going to go ahead and finish that real quick. This problem is related to the percent of people, 45% of adult Americans believe the overall state of the moral values in the United States is poor. And so we answered these questions already, A, B, using the binomial calculator in StatCrunch. And so now we want to answer C, D, and E. And so in this case, we still have these important values here, which we're going to end up using. So find and interpret the probability that that more than 16 of those surveyed would feel the state of morals as poor. So what we're calculating is the probability that X is greater than 16. And so then we're going to go use StatCrunch to do that. StatCrunch. Let me open it. Sorry about that. So StatCrunch is open. And then within there, you're going to, we're going to stat calculator binomial. And then we had our n is equal to, let's double check that. Our n is equal to 25, since we're asking 25 adult Americans. 0.45 is our n. So this would be 25, 0.45 there, and what we're looking for, greater than or equal to 16. Again, the normal, the binomial calculator shows the distribution of the probabilities for all the other answers. The ones we're interested in here in red, and so you end up with 0.0174. So there's our answer right there, 0.0174. So that's the answer for that one using StatCrunch, 0.0174 approximately. D, find and interpret the probability. Oh, so the interpretation on that, we should finish that. What does that mean? The interpretation should make sure that we really reinforce the idea. What does that mean? There is a very small percent, a 1.74% chance that, I'm going to fit it here, geez, that 16 people in 25 would state that the morals is poor in the United States, basically. So make sure we're using that language. There's this either 0.0174 probability that 16 people in 25 or out of 25 would state that the morals are poor in the United States. So we're looking at D, find and interpret the probability that 13 or 14 believe morals are poor. So on D, what we're looking at on D, that was C. For D, what we're looking at the probability of 13 or 14. Now, StatCrunch doesn't have that option, so another way I would think about that, you could do those individually. And so looking at if you're using StatCrunch, the probability of this would be equal to the probability of 13 plus the probability of 14. And so in this case, the probability of 13 is approximately equal to, using StatCrunch again, you would get an answer of 0.1236 plus this one here. So we had those two plus the probability of 14, just 0.0867. And if you add those, so that was 13, sorry. And then the probability of 14 is equal to 0.0867. So then the probability of 13 or 14 is equal to, when you add those two together, you're going to end up with 0.2103. And again, I got those from the binomial calculator. And so the hard part on this one is, like, how do you type that in? There is no, we could do the between, and so we want 13 and 14, so that we would compute that. So there's your answer there on the binomial calculator, 0.21, similar to what we got over here, 0.21. And then E, would it be unusual to find 20 or more adult Americans believe in the overall state they're poor? So what we're going to calculate on E is going to be the probability X is find 20 or more, so greater than or equal to 20. We do that calculation. Greater than or equal to 20, go back to a standard. Greater than or equal to 20, it needs to be an equal sign. Compute, it's 0.0003. 0.0003. And so in this case, 0. Let's fix this. 0. What's happening here? The answer is, something's going wrong with my pen. Wow. I'm not erasing right now. Something's up. So what's going on is that the answer is unusual. 0.0003. It's unusual. That's it.